Welcome to my YouTube channel Coulomb Academy. Friend, under this Coulomb Academy you will get the various videos related to vibration, mechanical vibration. Under this single degree of freedom, we have already covered the damped vibration and undamped vibration. Now today this lecture on the damped vibration, numerical, which will be helpful to you to clear your concept of vibration. So this numerical statement I will read it. दोस्तों, see, example is given to you for one mass of 7.5 kg. How much kg? 7.5 kg hangs from a spring and makes damp oscillations. How it will make the damp oscillation? You know, there is a damper, okay, and what will happen due to this damping? Time for 60 oscillations and in 35 seconds means what? The frequency we can calculate from this one, okay, and the ratio of the first and seventh displacement already we have studied. In that damped vibration, what will happen? The damping which will reduce or resist to the motion, and that will goes on reducing this C cycle of this every total damping cycle will be goes on reducing this amplitude, okay. So friend, here ratio is for this x1 and x7. These are the two amplitudes of this motion, wave motion or the sine wave. So what will happen? The ratio it is given is 2.5 x1 by x7. And like this 60 oscillations. How many oscillations? Suppose this point will start and up to this point one cycle will be there. Like this 60 oscillation, how many time required? 35 seconds are required. So what to find out? We have to find here the stiffness of the spring, okay, and damping resistance in Newton per meter per second. If the oscillation of critically damped and damping resistance is required, means what? In the critically damped, what is the value of that damping coefficient we have to find out? That is the value of C. So friend, here the given data it is written here. So given data, the mass is 2.5, okay. So I will just for understanding purpose I will draw here diagram. That means what? Here is the spring and one damper is there. See, this is the arrangement and this is the mass. This is the spring K and this is the C and this is the mass M. This arrangement and this X is given to displacement is given to this system, mechanical system. So here we have to find out your stiffness K. Here we have to find out the C, value C means what? Damping resistance or the damping coefficient we have to find out. And similarly third case is what? At zeta is equal to 1 means what? At critically damped condition we have to find out the C, value of C we have to find out. So three terms we have to find out. So we'll start with this first term, that is the what we have to find out? The calculate the stiffness. Step 1 means what? Calculate the spring stiffness K. K we have to find out. तो कैसे निकाल सकते हैं फ्रेंड अपन यहाँ पे? So we know that this formula, how to find out the K? K we can find out by using this omega n. Omega n is equal to, we already know, K by m. M we have value, but we don't know the value of omega n. Natural frequency पता नहीं है हमको. But we can find out this value of omega d. Means what? This damped frequency. Damped frequency we can find out by using this formula 2 pi f into d. So what is fd? 2 pi is a constant. So fd we can find out. Here it is written the fd means the frequency of damped frequency. How we can find out? Here see, in this numerical, this given data for 60 oscillations, total time is required 35 seconds. 60 oscillation 35 seconds. 60 oscillation 35 seconds required. So 60 oscillation, number of oscillation cycles per time, whatever the time required, that is your frequency. So we'll get the here value, and this value becomes 2 pi into fd. I will write here 2 pi into 1 point, how much here? 1.7143. So what is the value after this putting in the calculator, use the calculator, and we'll get the value 10.7712. And what is the unit for this one? Radian per second. So this is important. This value of omega d means damp frequency. Once we find out the value damp frequency, what we can find out? Where to find out the omega n? Omega n तो k निकालना है हम लोग को. Omega n we get the value of k. So what to find out? The omega n. So this to calculate this omega n, we require value of the, suppose this is formula we know, under root of this 1 minus zeta. Okay, 1 minus zeta square. ये रह गया था. So this is the formula. Through this we can find out the value of omega n. From this value we can find out the k. So friend, here what we have to do? We have to find out this value of zeta. Value of zeta we can find out by using the logarithmic decrement as per this logarithmic decrement. Okay, so what is that formula? Del is equal to for number of cycles, okay, n minus 1 into log to the base e, here x1 by x n. So this is the formula. See, this is the formula for logarithmic decrement. So I will write here again this equation. This del is equal to, so what is the n? In this case n is 7, because here it is given in the numerical itself of this x1 and x7. This last end is x7 is given in this figure also, you can visible to you x7. Okay, so we'll take the n is equal to here in this case 7. Means last cycle is given to calculate this key. Okay, thickness. By using this we have to calculate the stiffness. So I write here 1 by 6 means n minus 1 means 7 minus 1 into log to the base e inside the bracket, here x1 by xn means what? Value of n is, what will the here given? x1 by x n means x7. Okay, that we have to find out. So that ratio here x1 and x7 ratio we have, that we will write here 2.5. So solving this we'll get here answer. Let's solve by using the calculator. Just in calculator we'll get the value, put it all the values. That is the value of this your logarithmic decrement. So logarithmic decrement हम लोग को मिल गया है. So what is the use of this logarithmic decrement? We have to find out this value of the zeta. So what is the relation of this zeta? I will write here the equation. Okay, that equation is what? Zeta is equal to del upon 4 pi square plus del. This is your equation. This value we are just decrement value we are just find out here. Putting this value in this equation, we get the, this is the next formula to get this value of zeta. So how we can get the value now? Zeta, put here these values. So zeta becomes equal to value, just got it, 0.1527 divided by 4 pi square plus this value of logarithmic decrement square 0.1527 square. So यहाँ पे मैं क्लोज कर देता हूँ. So we'll get the value of zeta here. What is the value then? Just solving this simple under root of 4 pi square plus here this one square this term 0.1527 in bracket square. Okay, so हम लोग को ये वैल्यू मिलता है, we get the value 0.02429. This is the value of zeta. Okay, already we are the del value already we are calculated here. The zeta will be given. We can calculate by using this zeta. This omega n. How? See, this damp frequency and this omega n relation is there, that I will write here into under root of 1 minus zeta square. So we know this value of this one. Okay, we know the value of zeta. We can calculate the omega n. The values here, the 10 point I'll write here value of WD is the damp vibration. In this damp vibration, we have to find out the damp frequency. Already we are calculated 7712, which is equal to this omega n. We have to find out. Okay, into inside bracket 1 minus zeta. Zeta already we are calculated, it's square. So 0.02429 is square. So what will happen then? Solving this, we will get the value of omega n. इसको सॉल्व करना है, स्क्वायर करके इसमें माइनस करना है, रिड्यूस करके we get the under root, and this under root come in denominator on this side, and 10.77 divided by this one, we'll get the value of omega n is 10.774 radian per second. So this is your natural frequency. This is the value of natural frequency. Once we got the natural frequency, this is your natural frequency. So friend, here what we have to find out? Value of k. K is what? K is equal to, we have to find out. So omega n we know, omega n is equal to under root of k by m. M we know, so omega n also we know. So 10.774, which is equal to under root of k by m. M is what? This mass of this mass of the is given 7.5 kg. Mass is 7.5 kg. Here 7.5, I will write here 7.5. So from this we will get value of, here I will write the, due to space I will write here value of k. K is, we get the value, solve it, 870.67, and is Newton meter. Okay, so this is your value of k. We obtain the value of k. Friend, here this one term is where find out. This k where just solved and got the value. Now what we have to find out? We have to find out now the value of c. C means here c. How to find out the c? By using the formula to calculate the damping resistance. This is the damping resistance. Already it's asked in numerical. Damping resistance. Due to this damper, what is the resistance of this? We have to find out. How to find out the C? That formula is there. The C by Cc, which is equal to your damping ratio. The damping coefficient, resistance, this ratio is this one. Okay. Zeta we know here, and C and Cc, these values we have to find out. So Cc, how to find out Cc? Cc is given in numerical. Yes? No. So one more formula is there for similar for the zeta, that's C upon 2 into under root of this Km. This is the converted formula. So solving this, putting the values of Cc, just we get this one. Zeta is equal to C by. We know this value of zeta here. The value of zeta is nothing but the your just calculated here. Value of zeta, how much? This one. Okay. So 0.24 0.0 यहाँ पे 0 रह गया है ना, हाँ 02429. Okay, so I'll write here C we have to find out C upon 2 into square root of this K into m is 7.5. Here 870.67 into m 7.5. Okay, so we will get the here value of C. I will write the value of C is become 3.9256. इसका यूनिट क्या रहेगा? न्यूटन सेकंड पर मीटर. न्यूटन सेकंड पर मीटर. ओके, डैम्पिंग रेजिस्टेंस न्यूटन सेकंड पर मीटर. So similarly, what we have to find out? We have to find out this damping resistance. Damping resistance we have to find out C when this C is equal to Cc. Okay, that means what? That zeta becomes equal to 1. As critical damping, we can say the critical damping case. What is the value of C? So C is equal to Cc. If you put the value of C of Cc, so what will happen? Zeta is equal to 1. So we know this formula for Cc is 2 into under root of K into m. This is the formula for Cc, we know. So that as the Cc is equal to C, so 2 into under root of 870.67 into 7.5. So ये तो under root में है. So what is the value of C then? Last, this value of C at zeta is equal to 1 is 161.6159, and that will be in Newton second per meter. So this is the value of the C. How much value? 161.6159 Newton second per meter. When zeta is equal to 1 at critical damping. Okay, so this is the third point, this is the second point, and already we have calculated the value of K here. The first means what we have to find out? All the values are given to you. We have to find out the value of, we have to find out C, damping resistance, and damping resistance at when the zeta is equal to 1. So this value of C we will find out. So friend, like this number of values are there for this mechanical vibration. Please, if you subscribe my channel, subscribe it for the more and more video, and like it and share it more and more. Coulomb Academy. Thank you very much. What are the outcomes of this video of mathematical modeling for this all the vibrating system? Write down 3 outcomes, and friend, here you always learn by self-assessment only, and you have to subscribe my channel Coulomb Academy. If you are not subscribed, please subscribe it. Thank you very much.